Welcome back to the deep dive. Today we're getting into something really fascinating, aesthetic medicine. Specifically, how a laser can actually get your own body to produce new collagen. Pretty amazing stuff.
It really is. And our goal today, our mission, if you like, is to unpack the sophisticated process behind erbium laser dermal collagenesis. We want you to understand not just what it does, but how it cleverly commands your body's own natural repair systems.
Right, so it's not like the laser is adding collagen, it's more like a trigger.
Exactly. Think of it as a highly precise biological instruction, not a building material itself. It kicks off regeneration deep in the skin.
Okay, let's get into that precision. How does an aerial YAG laser achieve that? I understand its secret weapon is water.
That's absolutely right. Its wavelength, 940 nanometers, hits the peak absorption for water. And since our skin is, mostly water, this makes the laser incredibly efficient, very targeted.
So it heats the water, and then what?
Well, what's really clever is the mechanism. It's called photothermal ablation. The laser energy hits the water, and boom, it instantly vaporizes. It's like a tiny, controlled explosion that removes tissue layer by layer with amazing control.
Okay.
But here's the brilliant part. That vaporizing water acts like a heat sink. It uses up the laser energy, preventing it from spreading and damaging surrounding tissue.
Ah, so that limits the collateral damage, so to speak.
Precisely. Minimal thermal damage. That's what gives the AR-AIG its better safety profile and quicker recovery compared to, say, CO2 lasers, which spread more heat.
Okay, that makes sense from a physics perspective, but you mentioned it's also a biological command. This is where it gets really interesting for me.
Yes, absolutely. That precise, controlled injury, it's not just physical removal. It's a powerful biological signal. It kicks off this complex, orchestrated cascade of events. When you ablate those top skin cells, the keratinocytes, and cause that tiny bit of dermal injury, it triggers the release of all sorts of things, cytokines, growth factors, little messenger molecules.
Like sending out an SOS signal.
Sort of, yeah. So paracrine signaling, basically, cells talking to their nearby neighbors. They're telling the fibroblasts deeper down. Those are the skin's collagen factories, telling them, okay, time to rebuild.
Fibroblasts, right.
Okay.
So these are the cells that actually make the new collagen.
They are. And they actually transform into these specialized cells called myofibroblasts. Think of them as the skin's little architects.
Architects, I like that. So what do they build first?
Well, initially they synthesize type 3 collagen. This forms a sort of temporary scaffold, quick and dirty repair almost.
Okay, temporary.
But then over the next few months, and this is key, that type 3 gets remodeled. It's replaced by the stronger, more organized type I collagen. That type I is what makes up, 80-85% of adult skin. Provides the real structure and resilience.
And this remodeling isn't just passive.
Not at all. It's influenced by the physical forces within that new tissue matrix being laid down. It's a dynamic process, ensuring a robust, long-lasting result.
So that explains the wait time. People often wonder why they don't see the final results immediately after a laser session.
Exactly. It's all biology. You get that initial redness, maybe some swelling, peeling for, say, 5 to 7 days. That's just the surface healing.
Right, the immediate aftermath.
But the real transformations, the improved texture, the wrinkle reduction that unfolds over typically 3 to 4 months. It's delayed gratification directly tied to your body's own natural healing and collagen remodeling schedule.
Makes sense. Now, to make this even better, I know clinicians often use fractional lasers. What's the thinking behind that approach?
Fractional is a really smart refinement. Instead of treating the whole surface area, it creates these tiny microscopic columns of treatment microthermal zones, but leaves the skin between those columns completely untouched.
So islands of treated skin surrounded by healthy skin.
Exactly. And that untouched skin acts as a reservoir of healthy cells. It speeds up healing dramatically, cuts down the downtime, and really importantly, it minimizes risks like post-inflammatory hyperpigmentation.
That darkening some people get after skin injury.
Precisely. That's a bigger concern for patients with darker skin tones, maybe Fitzpatrick types 3 through 6. Fractional is often a safer approach there.
Okay, so less downtime, better safety profile, especially for some skin types. Is there any downside? Maybe the results aren't quite as intense initially compared to hitting the whole area.
That's a fair point.
Yeah.
Generally, yes, you might need more fractional sessions to achieve the same level of result you might get from one more aggressive full-field treatment. But for many patients, that trade-off, significantly less downtime, reduced risk, is absolutely worth it.
It really is quite a journey when you think about it. From a pulse of light hitting water.
All the way to your body rebuilding its own dermal structure, layer by layer.
Yeah. This whole deep dive really drives home how modern aesthetic treatments can work with the body, right? Intelligently guiding its own repair mechanism.
Absolutely. It's less about introducing something foreign and more about activating our own powerful inherent biology for real lasting change.
Truly fascinating. So, maybe a final thought for you listening. Where else in medicine are we seeing this? This idea of using subtle signals to prompt our bodies to create profound natural change. Where else are we learning to just give our body's inner architect the right blueprint?
That's a powerful question. Definitely encourages us to keep looking for those deeper connections in how our imaging bodies actually work.